Greetings to all. I am Arul Kumar, working as Assistant Professor in Department of Mechatronics Engineering, Kamaraj College of Engineering Technology. In this video lecture, we are going to discuss about filter circuits. In the previous lecture, we discussed about the diode bridge rectifiers. In diode bridge rectifiers, the AC contents present in the DC side is called as ripple. We need to reduce the ripple in the DC side. For that, we are in need of filter circuits. From the rectifier, we get a pulsated DC output like this, but we are in need of pure DC like this. So we need to have a filter arrangement. For that filter arrangement, here we are using this property. So an inductor allows DC and blocks AC. A capacitor allows AC and blocks AC. Here we are having an pulsated DC. By applying this pulsated DC into filter arrangement, we get an pure DC. Okay, an idea for understanding this filter operation. This is very much essential. Understanding this concept is very much essential. We will discuss how an inductor allows DC and blocks AC. Similarly, we will discuss how a capacitor allows AC and blocks DC. Here we are going to see how the inductor allows DC and blocks AC. So inductor is a device, electrical element, inductor L, and this is capacitor C. The reactance offered by inductor is XL and the reactance offered by capacitance is XC. An inductor allows DC and blocks AC. A capacitor allows AC and blocks DC. This is the symbol of inductor, this is the symbol of capacitor. The reactance offered by inductor is XL, the reactance offered by capacitance is XC. We are going to see the formula for inductive reactance. XL is equal to 2 pi FL, XC is equal to 1 pi 2 pi FC. So XC is equal to 1 pi 2 pi FC. In AC circuit is having frequency. Frequency is nothing but on cycles per second. Okay. So in AC circuit we are having an frequency. For DC circuit we don't have any frequency. It is a straight line. Okay. So in AC we are having an F value. In DC we are having F is equal to 0. Okay. So just we are going to substitute the F value into both cases. So AC circuit XL and XC value for AC as well as DC circuit. In AC circuit F value is there. So XL is equal to, it has some value. Okay. So XL value will be there. But in case of DC, F value is 0. Therefore, the capacitive, therefore, the inductive reactance F is equal to 0. By substituting F as into 0, we get an output as 0. So for DC circuit, the XL value is 0. In DC, we don't have any frequency. Therefore, we just substituted F is equal to 0, we get XL is equal to 0 for DC circuit. For AC circuit, we are having an frequency value, therefore we substitute F value, then we get the XL value. Okay. Then we are going to discuss about XC value. XC is equal to 1 pi 2 pi FC. In the first case, F value is there. Therefore, here for AC, XC is equal to 1 divided by 2 pi FC. So XC value is there. Then for DC, F is equal to 0. If you substitute F is equal to 0, 1 divided by 0, XC value will become infinite. So this property is very much essential to understand the filter concept. In AC, the reactance offered by inductor is XL. In case of DC, the reactance offered by L is 0. Similarly, the reactance offered by capacitance Xc, in case of AC circuit Xc value is there. In case of DC, Xc value become infinity. This property is very much essential to understand how the inductor allows DC and blocks AC, then how the capacitor allows AC and blocks DC. Okay. So, inductor is a device which is connected in series in the circuit. Capacitor is a device which mostly connected in parallel in the circuit. So, if you put inductor in AC circuit, it will offer XL value. Suppose if you put the inductor in DC circuit, it will offer 0 resistance. Therefore, an inductor will allows the DC current because the inductive reactance offered by inductance is 0. 0 means there is no opposition factor. Therefore, an inductor allows DC. And in case of AC, capacitive reactance Xc will be present. Okay. So, inductor allows DC because the opposition factor is 0. Therefore, it allows DC and blocks AC because we are having an XL value. Then if we are consider the capacitor, the capacitive reactance Xc, DC, in DC circuit, the capacitive reactance offered by capacitor is infinite. So, it blocks the DC current. Okay. So, it blocks the DC and then it allows AC. This property is very much essential to understand the filter circuit. Okay. We know that an inductor blocks the AC component and allow the DC component. That is why we are putting an inductor in series to the rectified output. Okay. So, here it allows only the inductor blocks the AC content present in the DC side and it allows a pure DC. Okay. So, we get a output like this, okay, filtered output like this. Then already we discussed that shunt capacitor filter, okay, shunt. The rectified output is passed through this filter, shunt capacitor. We discussed a capacitor allows AC through it and blocks DC. So, if you are connecting a capacitor in parallel to the rectified output, we get a filtered output like this because capacitor allows AC through it. So, it allows the AC content into the ground terminal. So, the AC content present in the DC side is properly grounded. That is why it allows only DC to the output side. So, the AC content present in the DC side, this will be grounded, okay, this will be grounded, and then the DC only, the DC content only present in the output side. This is the filtered output, okay, the output like this. Next we are going to discuss about LC filter. LC filter is made up of L and C. Already we know that inductor L will be connected in series and C will be connected in parallel. So, here we are utilizing an LC filter. So, the rectified output is passed through the LC filter and we get a filtered output like this. Here we get a smoother DC. The DC output is smoothen one. The AC content, it allows only DC. It blocks AC. It blocks AC. Okay. Here it grounds the AC content. The left out AC contents is passed to the ground terminal. So, the pure DC is allowed, pure DC. Here we are getting an pure DC. Okay. This is the advantage of LC filter. Then we are going to discuss about the pi filter. The pi filter is made up of, its configuration is looks like a pi symbol. So, in pi symbol, the first input side capacitor, then inductor, then capacitor. Like this pi arrangement, the filter components are connected in pi manner. That is why it is called as the pi capacitor. So, first the AC content present in the DC is passed to the ground, then the DC will enter into the AC circuit. The DC also is having a small amount of ripple, that ripple is blocked here. Okay. So, it is also allowing only DC, the AC contents present in the DC side is here, it is blocked, so it allows DC. Then again it is passed through the capacitor, it allows current flow to the AC content present in the output. So we get a purest DC, okay. So purest DC in output. So it smoothen the waveform, like this. Here it is approximately looks like a pure DC. This is the filtered output, okay. So we highly recommend pi filters to get a smooth DC output voltage. Thank you.